so let's start our lecture today. So yes, today I'm gonna cover something about the example of universal covering space. Okay, so start with the um, okay, so the uh, so okay. So for example is that the holomorphic universal covering map of the function plane C star. If the map gamma from C to C star given by z mapped to the exponential 2 pi I z. Okay, so what is this map? So here, basically you have the just the C plane, and then uh, so we define the exponential map by uh, so the exp of 2 pi z. Yeah, so the exponential map is just the usual way that you separate the real part and the imaginary part. So for the real part, you basically define it to be the radius. And then for the imaginary part, you define it to be the angle. Yeah. So and then uh for gamma is surjective locally by holomorphic mapping with local inverses given by a holomorphic branch of the multi-valued holomorphic function zeta maps to log zeta over 2 pi I. Okay, so um yes, so here this zero is this zero is being punctured out. Okay, and then this gamma is surjective uh locally by holomorphic mapping with local inverses. Okay, so why it is subjective? Because yeah, so it is surjective. Okay, so and then locally biholomorphic. So why is locally biholomorphic mapping? Because yeah, so the local inverse is given by the holomorphic branch of the log function. Yeah, okay. So and then giving a point, let's see, y0, which is equal to x naught plus yi naught equal to c. Okay. So here, if I pick the point here, okay, so this is z naught, maybe like here, okay. And then with x naught, y naught in R, okay. So we may form the connected neighborhood. Um, uh, u to be defined as rho e to the 2 pi I t, 0 less than rho less than infinity. And then okay, so the t the row value is all the positive numbers, and then the x values are the uh, it's a one half neighborhood between these t, right? So uh, okay, so here, so so you think of that as oh sorry, the one half neighborhood of this x naught. Okay, so here the x naught is like the real value, right? So here I pick the uh so this is like one half and one half here. And then oh sorry, so for the y value is strictly positive. So uh wait shoot. Uh where wait. Okay, so here I want to be a little bit careful. Okay, so okay, so this t is between okay, yeah, never mind. So this t is between one half and this t is between negative one half and positive one half. And then uh this row is between 0 and infinity, right? Uh so why this is a so how do I draw this? So how do I draw this? Yes. So uh it's now it's between one half. Okay, so for each okay, oh okay. Okay, so this neighborhood is in gamma of z naught, right? So yeah, so suppose that you have x naught plus uh I y naught. Then you take the exponential of it. Oh, so yeah, you take the exponential of the 2 pi I times the whole thing. So that's equal to the exponential of uh, 2 pi I x naught minus 2 pi y naught. Okay, so which is equal to um, the exponential of uh, uh, so okay, so 1 over the exponential of 2 pi y naught uh, times uh, okay, so 2 pi 2 pi I 2 pi x naught. So which is the angles, right? Um, so okay, so times the e to the okay, so maybe I use the sine. So sine of uh, sine uh 2 pi x naught uh comma cosine of oops, I think I ignored it. So it should be cosine sine. Okay, okay. Okay, so then you get that neighborhood. And then so the inverse image is the union of the collection of the domains. Yes. So here basically what you get is so when you take the minus, so here so this is just a point, right? So you map this point to the point where this x naught is being multiplied by 2 pi. Yeah, so yeah, so uh, yeah, so suppose that you have this one as your uh like 2 pi uh so suppose that this is like the gamma of the naught. Okay. And then when you increase the value of x by like a positive 1/2, so the angle will change by pi, right? But the angle will change by pi. So yeah, so it will like go there, like all the way, extended all the way, but doesn't hit this line. Okay. And then when you decrease the angle by a pi, so then it will be the same, right? Yeah. And then when you let the rho go from 0 to infinity, so basically what you're doing is that you are really uh, extend this line from like not hitting 0, but all the way to infinity along here. Okay. Okay. So now, so this is the neighborhood that uh so this is the neighborhood U. Okay. And then the inverse image gamma inverse U is then the union of the collection of disjoint domains. Yes. Uh, for each n, un is an infinite map. Uh, is mapped by holomorphically onto U by gamma. Okay. Yeah, so this is a fundamental example of the holomorphic universal covering map of the. Yeah, this is a fundamental example of the uh, holo of a holomorphic universal covering map. Okay, so we will continue next time about the uh, deck transformation group that is associated to this map. Okay.